Welcome to part 2 of episode 1 of Unearthing Data. Today we're talking about phytoplankton. In the last part of the first episode, we looked at the chlorophyll data for phytoplankton and we started to analyze it and look at the different patterns that exist in the data. Today, we're going to dig a little bit further. We're going to start asking questions about those patterns and hopefully learn something new about the phytoplankton phenomenon. In this part of the episode, we really focus on looking at connections in the data. We're going to first ask the right scientific questions about the patterns that we find in the data, and then we're going to try to answer these questions with evidence that we can find in our data dig. Then we are going to look at correlation and causation, and finally we're going to put it all together and make a data picture. Hopefully, what we learn by digging through the data will give a clearer picture of the phenomenon that we are interested in. So here are some of the patterns we identified in part 1. This table shows all the patterns that we talked about previously. When making questions, using any of these patterns when creating the questions will potentially give some good results and something interesting to look at when we start digging around in the data further. To first ask our scientific question, we need to take that curiosity we have about the phenomenon and put it into words. Here's a good template to start asking that question. First, you can ask a specific why question about any of those patterns that we identified on the last slide or in part 1. Ask, why is that pattern happening? Can I explain why that pattern exists at that location? Another way to write a question is to find two data sets that we think are related. Ask how is data set A related to data set B? These type of questions are important because there's a lot of relationships in earth science. Everything is connected. A lot of phenomena are connected to each other in many ways, so asking these questions starts to look at these connections to better understand the overall phenomenon that we are interested in. So here are some examples of the specific why question. In this example, I look at a subset of the phytoplankton map, and I'm looking at the phytoplankton concentrations off the coast of Brazil. You can see high concentrations right at the coast, so my simple why question might be, why are there high concentrations of phytoplankton off the coast of Brazil in January? Another example is this map here. You can see those low chlorophyll concentrations across the oceans in the black at 30 degrees south. My question here might be, why are those low chlorophyll concentrations present across the oceans at 30 degrees south latitude in January? Each of these questions is simple, but it is a specific question. So my tip is, when asking the scientific question, is to be specific with the location and the time so you can keep your investigation focused. Once you create these questions, write them down in your notebook. They're very important for the next step. Another example of a type of question that you can ask is, how is dataset A related to dataset B? When we talk about dataset A, we're usually talking about a dataset that describes the phenomenon that we're interested in. For phytoplankton, this means looking at chlorophyll concentration data for dataset A. Here are some tips for choosing dataset B. When choosing, you have a lot of freedom to choose whatever dataset to connect to dataset A. The key is choosing dataset B by making an educated choice. So do some research about your phenomenon from textbooks or any other source. Don't worry if you choose a variable or dataset that has no relation to dataset A. That's okay, and finding the lack of connection is sometimes just as important as finding a connection. Here are some datasets that you can try from the Earth System Data Explorer for dataset B. Here's an example of a question that fits the template to writing a good scientific question that we just discussed. Whichever type of question you ask, the next step is to find evidence to answer the question. This is the most difficult but most rewarding part of the dig. We are now looking for answers to our questions and creating explanations to answer the question why, or to better explain the relationship that we describe in our scientific question. So we're now going to go through a few types of evidence that can help you out in answering your question. First, we're going to look at collocation. This is where a feature in one dataset is in the same location and occurring at the same time as another feature in another dataset. To make this clear, here's an example. Here is a map of high concentrations of chlorophyll data that we saw a couple of slides ago off the coast of Brazil. And what I put here on the right is an image of the rivers that exist in Brazil and across South America. The river that is extending towards the phytoplankton maximum, that is the Amazon River. You can see that where the Amazon River meets the sea, we have a high chlorophyll concentration. This is an example of collocation. We have a major river, and in the mouth of that major river, where the river is entering the sea, we have a high chlorophyll concentration. So my data tip to you is when you're looking at collocation, you need to check to see if the pattern or the collocation that you see exists at different times during different months. For example, we see that this collocation of phytoplankton in the Amazon River occurs in January. We can check other months to see if this high concentration still exists in other months. The other type of evidence we're going to look at is correlation. To study correlation, we need to look at a bunch of values over time for each data set, otherwise known as a time series. Correlations ask if dataset A and B change the same over time. So in our example, we look at the monthly average sea surface temperature and the monthly flow of energy into the surface by shortwave radiation. We're going to look at a specific location in the North Atlantic, 50 degrees north latitude and 30 degrees west longitude. So if we look at a plot of these two time series at that location, you should notice that the increases and the decreases between the two datasets line up very well. You can see that when there are high values of sea surface temperature, there's high values of shortwave radiation, and the opposite is also true. This is an example of two datasets that are positively correlated. So when you're looking at correlation and collocation, there are a couple useful tools in the Earth System Data Explorer that you can use to look at these types of evidence. For correlation, you want to look at a time series line plot for variable A and B. You want to make a line plot over the same time period and at the same location for each plot, the location that you're interested in. When you look at these plots, you want to ask, do these lines increase or decrease at the same time? Does one increase while the other decreases? Here's an example from the Earth System Data Explorer. Find the menu here on the left sidebar of the Earth System Data Explorer and load a time plot. An advanced tip, you can also download the data from two time series plots and you can put them in Excel and use the correl function to calculate correlation. The higher the number that comes out of that function, the more correlated the data are. If the data move in the opposite direction, then the more negative number that comes out of the correl function, the more highly correlated the two data sets are. Another suggestion is to create two latitude and longitude maps to look at collocation. You want to make sure that your maps cover the same area and dates. For example, here is a plot of sea surface temperature and monthly chlorophyll concentration. Here on the left side of your screen, you'll see a compare to or a one plot menu that you want to choose. You want to choose compare to. Next, you want to choose the latitude and longitude to make the maps cover the same area. From these two maps, you can see that a higher chlorophyll concentration is co-located with cooler sea surface temperatures. So the last step, once you have the evidence, is to create your data picture. So answer these questions. How does your data or the results that you found fit your mental picture of the phenomenon? Does your correlation or collocations make physical sense? Because especially with correlations, you need to ask this question. You need to find a physical explanation of why the two variables are correlated. A common misconception or common mistake is to see correlation and to think that that's causation, that the two variables are connected and one causes change in the other, when in fact the two variables may not be related. or they may be related to something else that is causing the correlation to happen. And then ask this last question. Are you satisfied with what you found? Did you find the relationship that you were looking for? If you didn't, that's something that you can use to continue your studies, to continue the dig, and to keep digging until you're satisfied. This is your project, your dig. You want to answer the questions that you have, and you want to create your data picture. So take all these questions and then think about the phenomenon. Did you learn something by looking at the data? Do you know something now about the phenomenon that you didn't know before? That is the goal of your exploration. You want to find that nugget in the data to help your understanding. So now our dig is done. In this episode, we prepared for our dig. We got our notebooks. We understood the data that describes the phenomenon. In this case, we looked at chlorophyll concentration. Then we wrote scientific questions, and then we answered the questions with evidence. And then finally, we created a data picture and figured out how the new data fit within our picture of the phenomenon. If you do all these steps in order, you will have a successful data dig. Now that we've gone through all the steps, I hope you have a better understanding of how to do your data dig. I hope that you use what you learned here to go explore. Go dig through a data set and ask scientific questions, and hopefully you'll find a data nugget that answers those questions and helps you learn more about the phenomenon that you're interested in. So these steps presented here today are useful in any data dig or any data exploration. We will come back to these steps in future episodes. In the future, if you have any questions about the process, refer here back to episode 1. Thank you for listening, and thank you for being a part of the dig. I hope you learned a lot, and I hope to see you next time on Unearthing Data.